we worked with rectangles on Friday, and we determined that essentially the definition of the definite integral was essentially summing up all the individual areas, is what this is. So summing up all the individual areas, you take the limit as n goes to infinity, so you have an infinite number of rectangles, and it turned out to be the definite integral. So definite integral can be explained as being an area, the area under a curve, and that's where we kind of pick up and finish off today in 5.4 is finding the area under a curve and between two curves. Now this is a good news, because it is brief calculus, is that things don't get real sophisticated. So that's good news. Now essentially when you're looking at finding the area between two curves or under a curve, if it's between two curves, we're looking at an upper curve and a lower curve, and you want to find the area that's between. So how would you find the area that's between? Well, it's equal to the area that's under the above curve, so it's big, right? Then you subtract out the area that's below the curve, and when you subtract that out, you'll have the area that's between. Okay? So essentially, if I'm looking for the area between two curves, it's the area of the top one, subtract the area under the bottom one, and that gives you the area that's between. Now, if the bottom one is the x-axis, that would be essentially y equals 0. So, what's the definition of the area between two curves? It says if f and g are continuous with f greater than or equal to g, that means this is f is the guy on the top and g is the guy on the bottom. And then you're given between a and b, the area between two curves, namely f and g, is the integral from a to b of essentially the top one minus the bottom one. So if I were to look at this guy, the top one is x squared plus 1, right? The bottom one is y equals x minus 2. So what would be the area in between? Now we're looking at going from -1 to 2. I only want the area between those two elements, so it would be the integral from -1 to 2 of the top one subtract the bottom one. It's more than one term, so you need to put it in parentheses, dx. So top minus bottom. And that becomes a fairly simple integral to do. This is the integral from -1 to 2 of, there's only one x squared. This turns out to be what, a minus 2x plus 2. So this is going to be a minus 2x plus 1 plus 2 is plus 3 dx. And then you would take the antiderivative of that.
Hey, wait a second, Johnny. You're doing math in your head, so I'm...
No, I'm not. I'm doing it here.
Okay.
So minus 2
Yeah,
plus 2.
yeah.
Then you have an x squared
Okay.
minus 2x plus 1 plus 2 is plus 3.
Okay.
And now, this becomes x cubed over 3 minus 2x squared over 2 plus 3x evaluated from -1 to 2, and then I'll let you finish the problem. Then you put in the 2, and then you subtract whatever you do when you put in the -1.